Hello, everyone. So hopefully we'll have a little more stable platform for Call the Doctor this week. So I thought I would just go over some of the recent HSDS issues, enhancements, and so on. And then if anyone wants to continue the discussion we had last month about storage formats for AI task, we can do that as well. So let me share my screen. I will share. So I would like to give it a whirl and let us know how things are going. We had one user, this Ron Kuhn, has been pretty, trying things out and letting us know things that don't work and so on. So that's great. And then, so let me flip over to the HSDS repo. Let's look at some of the issues there. Well, let's start with the closed ones. Let me see. So Ron Kuhn was trying the RESTful, had an issue with running on Windows. And as I was talking about before going, I was able to, I don't have a Windows PC myself, but I ran Windows on VirtualBox and was able to figure out some issues, HSDS and Windows, and that should be good to go now. One thing about HSDS and Windows is that it's not set up to use the Windows version of Docker. So there's a script run all.bat, BAT, in the root directory, and that will run HSDS as a set of processes connected by sockets. Which should be fine. Let's see. And then this one is actually related. So this person was running runall.sh no Docker. So let me kind of walk through what's going on here. So it's bigger. Oops. Is this large enough? Can you see my screen? Or I'm not even sharing my terminal.
Right now, I see your browser.
Yeah, I need to switch the window, I guess. Do you see a terminal now?
I see a file browser.
I see the terminal.
I go this one.
There you go.
That's it. Yeah, good. So if I do Docker PS here, I see I'm running 9 Docker containers. So when you start HSDS up by default, it spins up a bunch of containers that run Docker, and these containers communicate with each other to provide like a multitasking, right? So we have these 7 containers, and each of them are effectively single-threaded. But by having these 7, they can utilize more of the cores we have on the machine. But say we don't want to run Docker for whatever reason. So let me see. Oops. This. So now I'm shutting down the Docker. Take a second. any data. Okay. And instead of doing run all.sh, I can do run all no Docker. And this will start the same set of processes, not as containers, but just as regular old processes. And by default, they'll communicate over Unix domain sockets. So here it's telling me at the end, use this endpoint. HTTP plus Unix is a kind of funky way to indicate it's a socket endpoint. So let me copy that and go over here and export HSDS endpoint to be that. And now if I do the test all script, okay, it goes through the same set of integration tests, but now rather than sending TCP requests to a container, it's sending HTTP through sockets to these subprocesses. And they're all right here. And you'll notice it says log file is /home/Sean projects HSDS hs.log. And if we look at that, we can see a lot of stuff. So here in this log file, it's all the processes write to the same file, and you'll have these prefix like DN1, DN2, DN3 to indicate which of the processes is writing to the file. And then we can shut this down by Control-C. And it says all subprocesses exited. So it's generally a little faster, I found, than using Docker. There's probably less overhead. The only real downside is that it can only work with clients on the same machine, right? If you want to use sockets, they have to be in that machine, not network-based. Okay. Anyway, there was some problem here, and it turned out that this user was not using Anaconda. So I typically use Python with Anaconda, which is like an environment where you can install Python and packages and not interfere with any system packages you have. And it turned out that when you install HSDS as a system package, there are some problems with finding the right executables. And this got sorted out. But overall, I would recommend using Anaconda. So let's here. This one, return group creation properties in GET request to group. So this was opened by Matt, who's working on the RESTful. So in the library, you can specify these group creation properties when you initialize a group. And they're mostly related to specifics of how the HDF library works. But for compatibility, it'd be nice that if you have these properties, you can use them when you initialize a group. And then if you need those properties later, you can get them. So this is useful to say, like, I have an HDF file, I create an equivalent HSDS domain out of it, and then I'm going to go back to create the same HDF file again. If I have access to these group creation properties, I can access those and then create the HDF file with those same set of properties. And so what we did is that we added this as a feature to the REST API, and you can now set whatever creation properties you want. We actually don't validate the specifics of what properties are being set, so you can basically pass any JSON in the request as your creation properties. Okay, this is Ron, who's been using the REST file again, and he's asking why variable length strings are not supported. Are there plans to support it? And I answered naively, they've been supported for ages. So we have like tests that use variable length strings in HSDS, and that works fine. And they're also supported with H5PD talking to HSDS. But what Ron actually wanted was support in the REST file. And that's a whole nother can of worms. So we haven't scheduled this feature for the REST file yet. If you plan to use REST file and you would like variable length strings, you might want to make a comment in this issue and let us know. If there's enough groundswell support, I guess we can tackle it. And one thing I'd like to mention, the way HSDS supports variable length strings is this mechanism where in the storage format, we store for each chunk, there is a integer that gives the size of the next element, the element, and then another integer for the size of the element, and so on. So that lets us store a chunk of variable length strings as one blob. And this has the effect, for example, that with data sets that have variable length strings, you can, or any variable length type, you can use compression, right? Which is not supported in the library currently. Right. Okay, this one was a user who wanted to use point selections. So, oftentimes with HDF5, we are doing hyperslab selections, right? You have a data set and you describe like a end and a start and a stride for each dimension, and you get all the data within that area. But there's another type of selection called point selections. And in point selections, the client provides a list of coordinates into the data set, and we return a set of values at those coordinates. So this user was trying various things to do a point selection, but it turns out that actually he was using gets. So in HTTP, there are 4 basic operations: get, put, post, delete. To do point selections, you actually need to use this post operation, and we document that here. Right. So you do post / datasets, this ID value, and you provide in the body of the request a JSON that says points and a list of coordinates. So this would be like the 1D case, right? In the 2D case, it would be like bracket, bracket, 2 points, close bracket, bracket, 2 more points, 2 more values, etc. So why is this a post and not a get? Well, when you do a hyperslab selection, it's fairly easy, since the number of dimensions cannot be ginormous, to have all the hyperslab parameters as part of the URL. But when you have points, you could have conceivably like tens of thousands of points in requests, and that would overwhelm the limit of the URL, at least for some browsers or some servers. So for point selections, we use a post request. And since in the post request, the point values, these coordinate values, are in the body, and that can be any amount of size to send. So that's just kind of background to why it's a post. So I should point out, we do have a repo called HDF REST API that lists, documents all the REST APIs. It's not totally up to date, but basically it'll, for each of the operations, to tell you what parameters are supported, how the body is formatted, and so on. Okay. this is another one that came from the work on the REST-file. So in HDF library, you can have contiguous chunk layouts, compact chunk layouts, chunk layouts. And hitherto in HSDS, it failed if you try to create a data set with either contiguous or compact. Because in HSDS, we always use a chunking scheme. This causes some problems for compatibility, right? So like if you have a C program that is creating contiguous data sets, it would fail if you switched over to the REST file. And so what we did now is to support contiguous compact, and by support, we mean that if you say you want contiguous or compact, we say, okay, and go ahead and create a chunked data set. So the result is you still get your data set, you just don't get this particular layout that's not supported in HSDS. All right. And then some open issues we have. This is this person noticed that there is a certain exception that we raise in HSDS, and it takes two arguments, and we accidentally had those two arguments swapped. So he pointed this out, and Dana was self-assigned this to himself and made a fix. So thank you, Dana. I think it's Dana's first contribution to the HSDS repo. It turns out there's two other places we have the same error, which Aaron pointed out, and I just put in a fix for that today. So I really appreciate people can spot problems. Here it's probably not impactful for most cases, but it's good anyway to have that. This one is another issue for this feature. In HSDS, you could iterate through links or attributes, but that iteration was always in a lexicographic order. And in the HDF library, it was possible to iterate through links or attributes through the creation order. And we actually store the timestamps for each object's creation in the HSDS storage format, so that wasn't a big deal to add the support. So we've gone ahead and implemented that. So I think if I go here, I can show you how it works. So like for the attribute test, here we have a bunch of attribute names like first, second, third to 12th. We create a bunch of attributes. And if you want to show them in creation order, you pass a special parameter called creation order equals 1. And if that's the case, you'll get these, if you list these attributes, you'll see them listed in the order first, second, third, fourth, fifth, so on. If you don't have that parameter, you'll get them listed in alphabetical order, which I think I have that listed somewhere. It'd be like 8th, 11th, 5th, 1st, 4th, 9th, so on. And the same kind of thing works for data sets as well. Okay. So you might say, well, it's not really a big deal. I could just get all of the links and sort them myself on the client side. But what if you have, say, a domain with tens of thousands of links, which got me thinking, I wonder how that works. So I went ahead and created a test domain that has a lot of links. What I did is I took every word in the English language, and I created a data set with that link name. And then I forgot what I stored as a value. I think it was some kind of scalar data set. But anyway, if I list this here, that was found. Okay, so is this going through and listing, I didn't create data sets, I created groups. So it's one group for every word in the data set. And if we do HSDS of this, we see that usually, the metadata storage is much less than the data storage. But here we have no data storage, no chunk storage used, 0 bytes. And the metadata storage is 14 megabytes. So it's rather more verbose than if you just listed all the words in the dictionary in a text file. But there's other aspects of each group that we have to store as well. And so we have, in the HSDS storage format, currently at least, all the links are stored in one JSON file. And it's rather large in this case. So if I do, say list dash all LH, let's try to track down this file. There's a little trick here to get to the actual file where this is stored. So this is basically where the group properties of this domain are stored in this setup, at least. So you see that this .group.json is 5 megabytes. So when a link has to be listed, the server has to read 5 megabytes of JSON and then read that into memory and then find a link and list it. So it's a little bit of overhead, but at least it scales to tens of thousands of links in one group, right? If we instead wanted like millions of links, we might need to make some changes, but I haven't had anyone come forward and say that's a use case they definitely need support. All right, Lori, how are we doing time-wise?
You have 4 minutes officially.
4 minutes, okay, and we're allowed to run over, right?
Yes, of course.
Okay, so anyway, let me go to the forum because there's some issues there. And I notice sometimes HSDS issues show up in the HDF forum. So there is a separate HSDS forum, so I would recommend using that. But it's fine if you want to post to the HDF. Actually, I don't see this issue.
Do you want to show? We see your terminal window still.
Oh, sorry. This time, yeah. You see my browser now?
Yes.
So like this person said, writing 1D float array to HSDS dataset depends on array length. I wasn't able to reproduce that, so I'm not sure what's going on there. And then we had another one. That was another one I didn't see. Oh yeah, HDF data are stored in directories, not in files. So this might have confused someone who just thought they were talking about library, but no, it's HSDS. All right. And just like I was showing that in HSDS, each group JSON, each dataset JSON is a separate file. And then each chunk of each dataset is a separate file. And this was designed to work more effectively with cloud storage. But it's just something to be aware of. Well, actually, you don't need to be aware of it, right? So you can pretty much never look at that storage pool. But you know, if something untoward happens, it might be useful to know that. So basically, you know, the interface works just like with the library, but the mechanism on how that data is stored permanently differs between the library.
And I just moved both of those threads to the HSDS category. So I can
Okay.
do that at any time. So you'll now find them in the right place.
Okay. Yeah, so I usually try to look at both the HDF Forum and HSDS pretty regularly, but if I miss, I'll be more likely to miss it if it's an HDF. And then this was an interesting post. So in when you have a HDF file, there's this utility to create a equivalent HSDS domain out of it. So you say hsload, file name, and then the target path you want. But there's also this thing where you can link to the original HDF data set. And now I'll need to switch my share again. Hold on. Let me go back to my terminal. Right place. You see a terminal?
Yes.
So if you run, say, hsload --link and some file, what it'll do is not copy all the chunks of the file to the HSDS domain. It will leave the chunks in the HDF file, and then the HSDS domain will keep references to those chunks in the original HDF file. So if I do HSList, so this S&P 500 is a file I ran hsload -link on. And we list it, we see that it's a group of the data set that has 3 million rows. And I wrote a little script to kind of show the kind of internal properties of this. And if I run this, so by the way, if you have HDF5:/ in front of the path, that's used to indicate that it's a HSDS domain in case you wanted an application that could use either files with the library or HSDS domains with the HSDS server. So here I say there's a data set, its shape is 3 million. Its type is V35, meaning it's a compound type with a bunch of fields. The dataset ID is D-75, blah, blah, blah. The chunks is 60,000, right? Meaning each chunk has 60,000 rows. And this layout is basically the type, how the data set is organized. And in this case, it's this class called H5D chunk ref indirect. And what that means is that it's a link to an HDF5 file. The file is actually this file, HDF5/data/HDF5 test/smp.h5. And we have another data set that's used to store the locations of the chunks. Okay, so this data set is here, and it's a anonymous data set, and its shape is 54. So if you follow, there's 54 chunks in this chunk table data set, and sorry, the chunk size is 54, right? But there's a bunch of chunks in this chunk table data set that reference the chunks in the HDF5 data set. And what the chunk table data set contains is, in this case, a bunch of tuples, right? And each of these is an offset and size. So here, this first chunk, this offset is 4,160 bytes from the start of the HDF5 file, and the size of the chunk is 2.1 million or so. So in this case, all the chunks have the same size, but it wouldn't be the case, say, if you're using compression. And then the offsets kind of iterate through the file. So I list the first 10 of these chunk tables. And then I list the first 10 rows of the data set. So when you access, say, row 0, it's going to go to say, okay, this row 0 is in the first chunk of the HDF5 data set. So I'll go to the first row of the chunk table. I'll get this offset and the size. I'll go here and read those bytes from the HDF5 file. So there's no interaction with the HDF5 library in this case, right? The HSDS is kind of directly pulling those bytes from the file. And then from that point forward, it flows just like any other HSDS data set would. And here, so we list these first 10 rows of the data set. So going back to this person's original question, he is wondering, is it better to use this -- link or not? And like most things, it depends, right? There's a small performance penalty using -- link because you have to go reference one data set to get to jump over to another data set and so on. In practice, the biggest performance difference is that with the -- link, you're forced to use whatever chunk layout the HDF5 file had. So if I have a HDF5 file with, say, 4 kilobyte chunks, and I run hsload on that, the hsload will resize those chunks on the fly. So it creates a chunk size that works better with cloud storage and such. If I'm using hsload -- link, then you're stuck with those 4 kilobyte chunks, and that can have some negative performance impacts in itself. The other thing is that if you already have a large collection of HDF5 files, then the amount of storage that HSDS uses is very small because most of the bulk of the data is still residing in the original HDF5 file collection. So if you have a lot of data and you don't plan to throw away those HDF5 files, right, you'll use less storage overall using the -- link option. Anyway, that's kind of a brief tour about that. If you had more questions, feel free to jump in on this forum post, and I'll try to answer. We're going to talk about the machine learning piece, but I guess I spent too much time going over issues and such. Maybe next time we'll resume that. Any other questions? Comments?
No, John, but if you do get to the machine learning stuff at some point in the future, that would be good.
Okay.
Because I think there's some points there that we didn't get to cover that are pretty relevant.
Right. Okay.
Okay,
Let's plan that for next time then.
Okay, thanks, John.
All right. Okay. Anything else?
Don't forget to register for a HUG event next. We hope to get the link coming up soon if you're thinking about speaking. We're hoping to find our speakers by May 21st. That's when the submissions are due. And then next week, Alexander will be our call the doctor person.
Okay.
All right. Thank you,
Okay,
everyone.
awesome.
See you later.
Bye-bye.